At 2:17 in the morning, the moon disappears. No explosion, no debris. One moment it hangs above Earth. The next, the brightest object in the night sky has become an empty patch of stars. Cities keep glowing. Earth keeps spinning. Gravity still holds us down, and our planet continues around the sun. The first surprise is how little happens, until people look toward the coast. The oceans do not leap into a single worldwide tsunami. Water already moving with the old tide keeps moving, but the force that organized most of that rhythm has suddenly vanished. Every harbor responds differently. Coastlines, seafloor shape, and narrow bays turn tides into complicated waves. Forecast tables become useless while residual currents collide with a new, weaker pattern. The sun still pulls unevenly across Earth, so tides do not disappear, but its tide-generating force is less than half the moon's. Over time, familiar tidal ranges shrink and schedules change. Mudflats remain covered longer. Other shores stay exposed. Tide pools stop refreshing on their old timetable, and creatures evolved around predictable flooding meet an ocean that no longer keeps the same clock. Ports would adapt. Engineers would remap currents, dredging, intake systems, and navigation windows. Some coasts might gain calmer water. Others would face stagnant channels and unfamiliar erosion patterns. Corals, turtles, insects, birds, and plankton would not all react the same way. The safest conclusion is disruption. Ancient biological calendars suddenly receive a blank signal where the moon used to be. Above from cities, the night becomes profoundly darker. Full moon brightness is gone forever. Predators lose hunting light. Prey lose a warning lamp. Navigators lose a familiar celestial marker. Human calendars survive, but their origin becomes strangely visible. Months, festivals, tides, night travel, poetry, and navigation all carry the fingerprint of a companion that is no longer there. Spawning, feeding, migration, and hunting can follow lunar light or tidal cycles. The change would not erase marine life overnight, but it would scramble signals used across entire coastal food webs. Solar eclipses vanish too. The extraordinary coincidence that lets the moon cover the sun ends instantly. Earth has lost not only a world, but one of nature's grandest alignments. Then comes the consequence nobody can watch in a lifetime. The moon's tidal pull has been stealing tiny amounts of Earth's spin and pushing the moon outward by about 4 centimeters each year. More important is Earth's tilt. Today, the moon helps prevent our axis from wandering too dramatically. Remove that stabilizing influence, and the planet becomes more vulnerable to gravitational nudges from its neighbors. Without it, Earth's current day does not suddenly shorten. Instead, most lunar braking stops. The sun continues a weaker version, but the long-term evolution of our planet's rotation changes course. This is not an instant flip. It unfolds across immense timescales. But larger changes in tilt could redistribute sunlight, strengthening or weakening seasons and moving climate zones across continents. Imagine future poles receiving stronger summer sunlight, or tropical boundaries shifting as Earth's angle evolves. The missing moon becomes a climate story measured not in storms, but in epochs. So the first night is not the end of the world. It is the beginning of thousands of local adjustments, darker ecosystems, altered coasts, changed currents, and a planet released from an old gravitational partnership. Its disappearance would teach us something unsettling. The most important structures in nature can be almost invisible. Sometimes stability is simply the force we stop noticing because it was always there. The moon seems passive because it never speaks or shines by itself. Yet its gravity moves oceans, flexes rock, slows a planet, steadies an axis, and gives living things a clock.